Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. So for this video we are going to discuss on basic laws. For the case of basic laws, these are things that you are going to learn. First, Ohm's law, nodes, branch and loops, Kirchoff's laws, series resistors and voltage division, parallel resistors and current division. Okay, so for the case of Ohm's law, it gives the relationship between current and voltage within a circuit element. The voltage across a resistor is directly proportional to the current flowing through the resistor. So you have there V, this one, V is directly proportional to current. Therefore, from this equation, from this relationship, it can be replaced with this equation, V equals to IR, or you can also write I equals to V over R, or R is equals to V over I. This R is called the resistor and it is measured in ohms, and it has the ability to resist the flow of electric current. This is the symbol for resistor. Okay, you check when for the case of passive sign convention, we assume that let's say you have this direction of your current. Okay, so the first terminal that current meets will be positive, and the terminal where the current left will be negative. This is based on passive sign convention. Okay, there are two extreme values for resistor. One is 0, another one is infinity. Okay, for the case of zero resistance here, because the value of the resistor is 0, so there's nothing that obstruct the current flows through, so you have a short circuit. Okay, when you have R is equals to 0, whatever the value of the current using the Ohm's law, you have V equals to I times 0, then V will be equals to 0. Okay, so bear in mind this is the case where when R is equals to 0, you have the case of short circuit. And when the resistor is equals to infinity, this is infinity, the value of the resistor is infinity, it's not possible. The resistance is very high, so the current cannot flow through, so this part becomes an open circuit. It's not possible for the current to flow through. So whenever you have R equals to infinity, your current will be 0. So in this case, your voltage will be infinity, and this is the case when you have an open circuit. Okay, conductance and power. Conductance is the reverse of the resistance. Normally, it is labeled as G equals to reverse of resistor. Okay, and since resistor the unit is in ohms, you just reverse the unit. So conductance, the unit is moles, or you can also use the unit in Siemens, but the most popular unit being used for conductance is in Siemens. Okay, and for the case of power, previously from chapter 1 you have P is equals to IV. So if V, according to Ohm's law, V is equals to IR. Therefore you have P is equals to I squared R, or if I is equals to V over R, then you have V squared over R, and the units for power is in watts. Okay, so let's solve for this example. You have 2 milliampere. Okay, this is independent current source, and the volt value is constant. 2 milliampere current flows through this 10 kilo ohm resistor. So again, current enters from positive terminal. When you want to label, current will enter from the positive terminal and leave from negative terminal. This is based on passive sign convention. So to find voltage, V is equals to IR. So V equals to IR. I is 2 amp and R is 10K. So you have 20 volt for voltage, and for the case of conductance, G is equals to 1 over 10k, which is equals to 1 over 10k is, let me check, 0.1, and K becomes millisiemens. Okay, and power P is equals to IV, so I is 2 milliampere and V is 20, so this becomes 40 millivolt. Milliwatt, sorry, this milliwatt. Okay, so you can do this on your own. Nodes, branch, and loops. Okay, these are important things when dealing with electric circuit. What is node, what is a branch, and what is a loop. Okay, let's say you have a circuit here. Ampere, 6 ohm, 5 ohm, plus minus 10 volt, for example. Okay, this current source. Okay, so for the case of branch, it represents a single element, for example, voltage, resistor, and so on. So in this example, you have 1 branch, 2 branch, 3 branch, and 4 branch, or 4 elements. Whereas for the case of node, it is the point of connection between 2 or more branches. Okay, and this part connects the 10 volt and 5 ohm. So this is your node number 1. Node number 1, and this part connects the 5 ohm, 6 ohm, and for 2 ampere. So this is node number 2, and finally this is node number 3. Or if you cannot see, you can redraw it such that it look like this. Okay, 2 ampere, this is your resistor, 6 ohm, 5 ohm, and positive, negative, 10 volt. So this is your node number 2. Here is your node number 1, and this is your node number 3. Whereas for the case of loop, loop is any closed path in a circuit. Normally, I prefer to consider the inside loop, these 2 loops. But you can also consider the outer loops. Okay. Bear in mind, 2 or more elements are in series if they exclusively share a single node and consequently carry the same current. Okay, how to show this? Okay, and let's consider this one. Okay, 2 or more elements are in series if they exclusively share a single node and consequently carry the same current. So let's check for these 2 elements, 10 volt and 5 ohm. Okay, here when this current flows through this part of the network, these 2 elements, current does not split, so it has the same current. In this case, 10 volt and 5 ohm are in series. Okay, so you check whether you have the same current or not that flowing through the same element, flowing through the different element, then if you have the same current, then the two elements are in series. Okay, for the case of the parallel connected circuit, two or more elements are in parallel if they are connected to the two same nodes and consequently have the same voltage. Okay, this element, for example 3 ohm and 2 ampere, they are connected to the two same nodes. Okay, similar to the 2 ohm resistor. So actually you have all of these three elements are in parallel because they are connected to the two same nodes. Okay, so please make sure you are able to differentiate between series connected elements and parallel connected elements. Okay, let's consider this example. You need to find how many branch nodes and nodes in this circuit, and you also need to identify which elements are in series and which are in parallel. So we already discussed on the elements that are in series and in parallel. So for this example, the number of branch that you have here is 5, right? 1, 2, 3, 4, 5. And already labeled there, you have 3 nodes. 1, 2, 3. Okay, and for this circuit, how many branch? 1, 2, 3, 4, 5, 6, 7. 7 branches. How many nodes? 1, 2, 3, and 4. Okay, and the elements that are in series are the 30 volt and 10 ohm. Okay, 20 ohm and 30 ohm are not in series because if you check here, once, let's say you have a current here, once it reach this node, it will split into, okay, sorry, let's say you have this current, once it reach this node, it will split into two. So you don't have the same current that flows through 30 ohm and 20 ohm. So they are not in series or parallel. And for the case of parallel connected elements, 60 and 40 are in parallel because they are connected to the two same nodes and similar to 2 ampere and 30 ohm. Okay, that's about the node, branch and loops, where for the case of Kirchoff's current law, you will focus on a node or closed boundary. KCL states that the total sum of the currents entering or leaving a node or a closed boundary equals to 0, or the equation given, currents entering should be equals plus current leaving should be equals to 0. Normally we label the currents entering a node as positive and currents leaving a node as negative. So let's say here you have, this is your node and you have 2 ampere current, and here is your I1, for example, here is your I2. So let's say you want to write the relationship, the KCL equation for this node. The current entering is 2, the currents leaving are I1. Okay, we put negative here because stated here leaving a node should be written negative minus I2 equals to 0. So if you rewrite this equation, you have something that looks like this, I1 plus I2. So you can also write currents I entering equals to I leaving. Okay. Okay, so let's write the equation for this node. You have current I1 entering plus I3 also entering, plus I4 entering, whereas current I2 leaving, I5 leaving, or you can also write equals this one. I1 plus I3 plus I4 equals to I2 plus I5. And also for the case of closed boundary, this is the closed boundary, and for this case it is as if you don't know what's inside the boundary, you just know within each boundary whether the currents are leaving or entering. So these are the boundary. Okay, in this case, let's label the current I1, I2, I3, I4. So for this closed boundary, okay, you have this one also, I5. For this closed boundary, you have current I4 entering plus I5 entering equals I1 plus I2 plus I3. Okay. Okay, let's solve for this example. In this example, you were asked to find current I1, I2, and I3. Current I1 is here. Where to find current I1? You can choose the lower node or the upper node. Okay, so it's up to you. Regardless of the node that you choose, you are going to get the same answer. For current I2, you can choose the B node or the upper node, and for the current I3, you can choose C node or the upper node. Okay, let's solve for I1. Okay, if you choose the lower node, you have there 4 ampere. 4 ampere is entering while the rest are leaving. So I1 plus 10. Oops, 10 is also entering. Plus 10. Therefore, your I1 equals to 14 ampere. For the case of current I2, let's solve. Let's choose the B node, because if you choose this node, you have two unknowns, your I2 and I3, so it will be more difficult. So if you choose node B, you only have one unknown. So for this node B, current entering is 12, current leaving equals to 14 plus I2. So I2 is equals to minus 2 ampere. And finally, you can choose for the upper node or the lower node for I3. Let's choose this node. You have 14 entering, the rest are leaving. So I3 equals to 10 ampere. Okay, that's about KCL. So bear in mind, for KCL, you need to identify a node before you can write the KCL equation. Whereas for the case of KVL, Kirchoff's voltage law, it deals with a loop. Okay, KVL states that the total sum of all voltage around a closed loop or path is 0. So total voltage rise plus total voltage drop should be equals to 0. So let's say you are given this circuit and the polarity of each element already been assigned. So in this case, whenever you need to apply KVL, you need to draw an arrow, okay, either in clockwise or counterclockwise direction. It's up to you. So in this case, let me choose the clockwise direction. If I start from this Vs, I will see the negative terminal of Vs first, minus Vs, and then plus V1, plus V2, plus V3 equals to 0. So your Vs is equals to V1 plus V2 plus V3. So if you want to verify whether you are going to get the same answer for counterclockwise direction, okay, so let's assume this direction. You have, starting from Vs also, Vs and then minus V3 minus V2 minus V1 equals to 0. Rewriting Vs equals to V3 plus V1, sorry, V2 plus V1, which is the same as the upper one. Okay, let's change the polarity. So let's say instead of being given positive here, you have negative and positive, and you were asked to find the KVL equation. So in this case, the new equation becomes minus Vs minus V1 plus V2 plus V3 equals to 0. Rewriting Vs plus V1 equals V2 plus V3. Okay, so let's solve for this example. Find V1, V2 and V3. So for V1, let's first draw the arrow. Okay, for V1, if you write the equation, we start with 20 volt, you will see negative first, minus 20, minus 25, plus 10, plus V1 equals to 0. So V1 is 35 volt. Okay, and for V2, you cannot solve this part yet because you have two unknowns. So let's solve for this part. Plus 15 minus V2 minus 10 equals to 0. So V2 equals to 5 volt. And for V3, minus V1 plus V2 plus V3 equals to 0. V3 is equals to V1 minus V2 equals to 35 minus 5 equals to 30 volt. Okay, alright, let's move to example 8. Okay, for example 8, you were asked to find V0 in the circuit below. Okay, before you can solve for V0, how are we going to solve for this circuit? Okay, let's find, in order for us to solve for V0, we need to find the voltage here and the voltage here, right? But in order for you to find the voltage in these two elements, you need to know the currents. Okay, so again, you are going to use Ohm's law and KVL, where let's label here, let's draw an arrow. Let's call this current I. Okay, and for the case of passive sign convention, positive, this current will flow through positive terminal of 6 ohm first, and then negative, positive, negative. So let's call this as our VA and VB. Okay, for VA, using Ohm's law, VA is equals to Ohm's law. V equals to IR. You have the R there, 6 ohm, and your I is this current, right? Because you have the same current that flows through the part of the network. So you have I6 for VA, or 6I. Okay, and the same current flows through the 2 ohm. So you have VB equals to 2I. Okay, that's for the case of the Ohm's law for 6 ohm and 2 ohm, to find the voltage at 6 ohm and 2 ohm. And then you need also to apply the KVL. So for the case of KVL, going clockwise, you have minus 9 plus VA plus VB plus 3 equals to 0. So, substitute VA equals to 6I plus 6I plus 2I plus 3 equals to 0. 8I equals to minus 9. 9 minus 3 is 6. So your I is equals to 6 over 8. 0.75 ampere. Okay, so if VI is 0.75, your VA will be equals to 4.5 volt. Your VB equals to 1.5 volt. But the question wants you to solve for V0. Okay, how to solve for V0? Let's redraw the circuit. Plus minus 3 volt. This is your VB. Plus minus 9 volt. And here is your VA. Okay, and you are interested with V0, which is located here. So again, even the network is an open circuit or it is not closed, you can still apply KVL. So there are two loops here. You can either choose this loop for V0 or this loop. In the end, you are going to get the same answer. Or if you want to apply KVL for this part of the network, the equation is, you will see negative terminals first. So minus 9 plus VA, which is 4.5, plus V0 equals to 0. So V0 is equals to 4.5 volt. Okay, that's the case when you consider this part of the network. If you consider this part of the network, you are going to get the same answer. So let's verify. Minus V0 plus VB is 1.5 plus 3 equals to 0. So V0 is equals to 4.5 volt. Okay, and for example 9, in the circuit you are given an independent source and a dependent source, and this dependent source, the variable here depends to this 5 ohm resistor label here. So for this case, Vx is label positive up and negative down, but the polarity can be changed depending to the question. Okay, let's solve for this circuit again. This circuit, all elements are connected in series, so you are going to apply KVL and Ohm's law. For this one, let's call this as I. This one I don't want to call it as V1, VA for example. I know directly the equation here is 1I or I, right? And here is 5I, right? And for this part, label positive, negative, positive, negative, positive, negative, and here is 2I. Or if you are still confused, V1 ohm is 1 times I. V5 ohm is 5I. V2 ohm is 2I. Okay, so writing the KVL equation, minus 15 plus I plus 2Vx plus 5I plus 2I equals to 0. You have there 5, 6, 7, 8. 8I plus 2Vx equals to 15. Okay. 8i plus 2vx equals to 15. Okay, next we need, because we have two unknowns here and one equation, where can we get another equation? From here you have Vx. Based on the polarity of Vx, it looks that current is coming from this direction. So positive, negative, meaning that Vx is equals to 5i. Okay, so directly substitute Vx equals to 5i. You have 8i plus 2 5i equals to 15. This is 10i. 18i equals to 15. 5i is equals to 15 over 18. Therefore, your Vx is equals to 5 times 15 over 18, which is equal to 4.1667 volt. Or let's see, in this example, Vx is labeled here. What if I change the labeling, the location of the Vx? Okay, I want to label Vx here. Okay, so if Vx is labeled here instead of here, you check the direction of the current. Okay, so we, based on our assumption, current is moving in this direction, but given the labeling of the Vx negative is here, so it means that current is in this direction. So when writing the equation, Vx is equals to negative 2i, because it is in different direction of the assumed current. Okay, so you have Vx equals to minus 2i, and you just substitute into this equation again. Oh, sorry, this one, if Vx is located here. So 8i plus 2 negative 2i equals to 15. 8i minus 4i equals to 15. 4i is equals to 15. I equals to 15 over 4. Okay, and then to find Vx is equals to this one, minus 2 15 over 4. Okay, you can solve this on your own. Okay, so that's all that I want to cover in this video. We will discuss on the series resistors onwards in the next video. Thank you.